All right, welcome. Today, we're diving into what I think is a pretty epic mathematical duel. It's a story all about the quest to find some kind of order in the total chaos of prime numbers. And this isn't a battle of swords, it's a battle of two incredibly powerful ideas, represented by these two functions, j of x and psi of x. Okay, let's just jump right into this. Prime numbers. I mean, they're like the basic building blocks of all numbers, but they seem to pop up almost randomly. There's no simple, neat formula that just tells you what the next one's going to be. For centuries, this beautiful chaos has been one of the biggest challenges in all of math. So, how in the world do you even begin to map a territory that looks like it has no rules? Well, you definitely don't map this kind of territory with a simple ruler. No, you have to forge entirely new tools. And today, we're going to explore two of the most important ones ever created for this job. And we're going to uncover the fascinating story of how one basically evolved from the other. So, let's meet our two contenders, Riemann's Joy of X and Chebyshev's Psi of X. Now, both of these are designed to count primes, and this is the key, they do it in fundamentally different ways. Their whole secret lies in how they weigh each prime number they come across. First up is Riemann's J of X. Think of it kind of like a voting system. When it counts a prime number, say the number 7, it gives it one full vote. But when it comes across that prime squared, so 7 squared, which is 49, it only gets half a vote. And a prime cubed? That gets just a third of a vote, and so on. The higher the power, the less say it has. And now for Chebyshev's Psi of X. This function has a totally different philosophy. It also counts prime powers, but it gives every single one the exact same weight. And that weight is a special value, the natural logarithm of the original prime. So 7, 49, and 343 all add the exact same value, log of 7, to the total count. It gives each prime's entire family a constant, powerful voice. And right here, this is the absolute core of the difference. J of x has that diminishing weight, while psi of x uses a constant one. This one little change has massive implications. It even changes how they hook into the legendary Riemann zeta function. As it turns out, the connection for psi of x is just mathematically cleaner, which is a huge reason it became the tool of choice for doing proofs. But here's the thing. These two functions didn't just appear at the same time. They actually represent this decades-long evolution of one single, powerful idea. The story really starts to make sense when you look at it on a timeline. So, back in 1859, the legend himself, Bernhard Riemann, publishes this groundbreaking paper. He introduces J of x and a mind-blowing formula that connects primes to the zeros of his zeta function. It was like a master key to understanding primes. But, and this is a big but, his argument was more of a brilliant sketch than a finished, rock-solid proof. It actually took 36 years, all the way until 1895, for Hans von Mongoldt to come along and make Riemann's ideas totally rigorous. And how did he do it? He switched to the psi of x function. And this, of course, leads us to the big question. If Riemann's idea was so revolutionary, why did von Mongoldt, and basically all of modern math that followed, switch to a totally different function? Why try to fix something that wasn't, technically broken? It really is the classic story of the visionary versus the pragmatist. Riemann, he gave us this breathtaking, world-changing vision with J of x. He saw a connection no one else could even imagine. But it was von Mongoldt, the pragmatist, who came along later and basically said, "This is absolutely brilliant, but I can build a much cleaner, stronger, more useful tool to actually get the work done." And that tool, that was psi of x. So why did psi of x become the standard? Well, to put it simply, it's just the superior tool. Its properties are cleaner, its link to the zeta function is more direct and simple, and it's way, way easier to handle when you're doing the really rigorous work of proofs, like the one for the prime number theorem. Riemann's function might have been the beautiful, poetic idea, but psi of x was the powerful engine that could actually take you there. So where does that leave us today? Well, in the modern world of mathematics, a pretty clear choice has been made. Mathematicians honor the profound, incredible vision behind G of x, but when it's time to roll up their sleeves and get to work, they pick up the tool that gets the job done most effectively. This quote just perfectly captures the whole story. It really highlights a fundamental truth about how science works. Progress isn't just one lightning strike of pure genius. It's a visionary spark that's then followed by the really hard work of refining that spark into a tool you can actually use. So you see, this was never really a duel about which function was correct. J of x wasn't wrong at all. It was the essential, brilliant first step. This is really a story about refinement, about how a brilliant idea becomes truly powerful when it's polished and perfected into a practical tool. And that right there is the essence of how science and math really move forward. And that leaves us with a final thought to chew on. Riemann's incredible, visionary idea had to wait 36 years for its perfect tool. It really makes you wonder, doesn't it? What groundbreaking, visionary ideas from today are just sitting out there, waiting for their own von Mangold to come along and forge them into the practical, world-changing tools of tomorrow?